In the last lesson, we finished the first part, that is the geometric meaning of zeros of a polynomial, and we concluded this idea. Okay, that if polynomial is an nth degree polynomial, and there will be at most n zeros, and if you draw the graph, there will be maximum n intersecting points with x-axis. So the x-coordinates of the intersecting points are the zeros of given polynomial. Okay. So now we are moving to next topic. Okay. Next topic is the chapter we divided into 3 parts. So second topic is relationship between zeros and the coefficients of a polynomial. Okay, or is there any relation? Okay, that's what we check here. So here for first degree polynomial, for linear polynomial, we have already studied in 9th standard, and we also discussed first and second and third lessons. Zeros of a linear polynomial x plus b is minus b by a. You know that, right? So the zero, to get the zero of a polynomial x plus b, take the negative of the constant term and divided by coefficient of x. Okay, so minus b by a. Okay, this is very simple. You already know this. And now the topic is quadratic polynomials. Is there any relationship between the coefficients of a polynomial, second degree polynomial, and the zeros of the polynomial? So general form of a second degree polynomial, you know that p of x is equal to x square plus bx plus c. And we give names for the zeros, alpha and beta. These, you know, these two symbols, these two letters, alpha and beta. Have you seen this before in physics or chemistry? No. Okay, so these are two Greek letters, alpha and beta. In mathematics, we always use this. Not only in polynomials, in many branches of mathematics, we use Greek letters. You know, pi is a constant, right? Pi, 3.14, etc. Yeah?
Yes.
So for pi is a Greek, I think, Greek letter. So similarly, alpha and beta. So we use to represent constants. We are seeing that alpha and beta are the zeros of this second degree polynomial. And a, b, c are the coefficients. A, b, c are the coefficients. A is the coefficient of x square, b is the coefficient of x, and c is the coefficient of x raised to 0. We can also say that c is the constant term because x raised to 0 is 1. Okay. So the relation is the sum of the zeros will be minus b by a. The negative of coefficient of x divided by coefficient of x square. And the product of the zeros will be c by a. That's a coefficient of x raised to 0, or the constant term divided by coefficient of x square. So these are the relation between coefficients of a second degree polynomial and zero of a second degree polynomial. Okay, sum of these zeros will be the negative of the coefficient of x divided by coefficient of x square, and the product of these zeros, alpha and beta, alpha beta, is equal to the constant term divided by coefficient of x square. X is a variable, right? X is a variable, but a and b and c are constants, and also alpha and beta are constants. Okay, so Greek letters alpha and beta you will also see in some other places in mathematics, also in physics and chemistry. Okay. We'll see some examples now. Is this relation correct? We will take some examples and we'll check are the sum is equal to minus b by a, and is the product equal to c by a. We'll check it. And also we'll prove, using algebra, we'll prove that alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. Okay. So I shall open whiteboard. Okay. I take one second degree polynomial. P of x is equal to 2x square minus 8x plus 6. Minus 8x plus 6. We are checking, is this correct? Is alpha plus beta is equal to minus b by a, and is alpha beta the product of the zeros c by a? We want to check these two. Okay, so here what is A? What is A? Compare with the general form. Compare with x square plus bx plus c. What is A here?
2.
A is 2. What is B?
8.
Minus 8.
Minus 8.
Minus 8.
Minus 8. Very good. What is C?
6.
6. So keep this in your mind. Keep this in your mind. We will use it. Okay. So before that, we want to find the zeros. Zeros are not directly given. We want to find the zeros. Okay. For that, in 9th standard, you have studied how to factorize it. How to write a second degree polynomial as the product of two first degree polynomials. Okay. So for that, there is a technique. Suppose our polynomial is 2x square minus 8x plus 6. So you have to split the middle term. The x term you have to split in such a way that if you multiply those two splitted terms, you want to get 2x square into 6. 2x square into 6 means 12x square. Okay. So when you split this minus 8x, then if you multiply those two terms, you have to get 12x square. In such a way, we will split minus 8x. So how can we split? 2x square, same here. I write 2x square. And minus 8x, you have to split. Minus 8x. How can we split it? Okay, the sum will be minus 8x. I said we are splitting minus 8x. We are not writing anything new.
Sir,
okay.
minus 2 minus 6.
Minus 2 minus 6. Okay, minus 2 and minus 6. Very good. Minus 2x and minus 6x. Okay, minus 2x and minus 6x. What we did here? Minus 8x is equal to minus 2x minus 6x, right? 8x minus 8x is equal. Minus 8x is equal to minus 2x minus 6x, right? Minus 2x minus 6x means minus 8x. So we just split minus 8x as minus 2x minus 6x. Okay, this is nothing you have studied in 9th standard, how to split. This is why we do this, to factorize. To factorize. In next step, you can take something common outside the bracket. Okay, from the first two terms, 2x square minus 2x, you can take 2x outside. You can take 2x outside. So how will come that? Take 2x outside. So if you take 2x outside, what will be inside bracket?
X minus 1.
Minus 1.
X minus 1. Okay. Then from second two terms, you can take something outside the bracket. You can take minus 6 outside the bracket. So I take minus 6 outside the bracket. So what will be inside the bracket?
X minus 1.
X minus 1, right? So from these two terms, 2x into x minus 1 and 6 into x minus 1, you can take x minus 1 in common outside the bracket. Okay, so how will be that? X minus 1 we take outside the bracket. And what will be inside the bracket?
2x minus 6.
2x minus 6. Okay, so what we did, we factorized it. We made the given polynomial as the product of two first degree polynomials. Okay, so here to find the zeros, means we are finding the values of x. For that, p of x is equal to 0. Okay, so if p of x to be 0, for this to be 0, this should be 0. Product of two first degree polynomial to be 0, there are two chances. One, x minus 1 is equal to 0, or 2x minus 6 is equal to 0. So two chances are there. So x minus 1 is equal to 0 means what? What's the value of x? X is equal to
1.
1. X minus 1 is equal to 0 only if x is equal to 1. And 2x minus 6 is equal to 0 means what is the value of x?
Minus 3.
3.
Yes. 3 or minus 3? 3.
3.
Okay, minus 6, if you move to right side, it will become plus 6. So 6 by 2 is 3. Okay. So the zeros of these polynomials are x is equal to 1 and x is equal to 3. If you find P of 1 and P of 3, P of 1, if you calculate it, this value will be 0. And P of 3 will be also 0. Okay. Now we want to check. We got alpha, simply call this as alpha and this as beta. Now we want to check whether the sum of the zeros is equal to minus b by a, and is the product is equal to c by a. Okay. So simply add alpha plus beta. That's 1 plus 3. So 1 plus 3 is 4. 1 plus 3 is 4. And now just take minus b by a. Minus b is minus 8. So what is minus b? What's
8.
minus b? Yes. So minus b by a here is 8 by, what's a? A is
2.
2. A is 2. So 8 by 2 is 4.
4.
So here alpha plus beta we got 4, and minus b by a also we got 4. Okay, so for this example, alpha plus beta is same as minus b by a. Now we will also check the alpha into beta. What will be alpha into beta? So alpha is 1, beta is 3, so 1 into 3 is 3. So we will also check c by a. Is c by a 3 or not? C by a is equal to what? C here. Look, the polynomial. C is 6, right? So you write 6 here. 6 by what's a? A is 2, right? A is 2, so we substitute the value 2 here. So what is 6 by 2?
3.
3. So we got alpha into beta, we got 3, and c by a also we got 3. So that means alpha into beta is equal to c by a. So both the result are true in this case. Okay, so alpha plus beta, sum of the zeros is equal to the negative of the coefficient of x divided by coefficient of x square, and the products of the zeros is equal to coefficient of x raised to 0, that is constant term, divided by coefficient of x square term. Okay, so these two results you have to memorize, you have to apply to solve different types of problems.